My name is Kevin Dupont. I'm from the company called the RVT Group. Today, we're going to be focusing on negative and positive pressure systems. You'll probably be aware, especially negative pressure systems being used with contractors like asbestos contractors with good reason. It's a very 100% effective way of containing hazards in a lot of situations. Also positive pressures as well, how that can be used, especially in construction industry, protecting often our clients' interests. Environments where we need to be absolutely certain with protection of not just ourselves, our colleagues and anybody affected by our work, but really focusing on how we can protect areas around our working zone. Could be the client, it could even be our trades, our colleagues themselves. What is negative and positive pressure? What we're talking about here is airflow, how we can use airflows in different ways to stop transmission or migration of hazards. We're not talking about hazards, I'm really referring to hazards like dust and fume, especially dust that you can't see, silica dust, for example, or fume. Again, you can't see it. So how can we be certain of containing it? And that's really where this negative and positive pressure systems can really work for us. It could be nuisance dust, where you need to protect a client's interests. Perhaps you're working alongside a food processing plant, or maybe in industry where there could be some significant assets close by to where you're working and you need to stop nuisance dust or large particulates dust contaminating areas. So when we look at negative pressure to start with, what this really means is we need to extract air out of an area with a fan, obviously, and sometimes a filter. It depends on the hazards that you're working with, but the point here is we're extracting out, taking it from within a space, within a building, within a room, within an area, and taking it outside via the fan or ventilation system. On positive pressure, we're doing the complete opposite, and is often used for purging or purifying type principles, where the fan is the other way around. It's outside that space, outside that room, outside that building, and pumping in air to form a positive pressure. So what this is actually doing is stopping any contaminants outside that zone, that area, that space, stopping those hazards migrating in. So it's the reverse of the negative pressure system. So looking deeper at negative pressure, you can see on the screen there the arrows pointing into that building. And that is the makeup air coming back in. So as you take air from within that building and pumping it out, either with or without a filter, depending on the hazard, as air's been taken out, air's got to come back in. And it's that principle of the air coming back into that building or that space creates that seal or negative pressure. So what that's really doing is changing the weight of the air in that area, lowering the pressure. As you take air out, it lowers the pressure. And this would be used a lot with asbestos type companies to stop that migration of a dangerous substance spreading outside their work zone. Could often be used in food processing situations, industrial situations, or could even be used on a building site where you may be working with a particular hazard, processing it, cutting it, preparing it, whatever it is, working in a nominated area, a screened off zone, a nominated room, anything like that. And the most effective way to stop it spreading, especially that fine dust that you can't see, is to put it under a negative pressure. And that protects the environment outside that cutting zone where people are not going to be protected by PPE, for example. Other areas where we often use negative pressure, you can imagine a hospital environment. Very rarely does a contractor get the opportunity to have full run of a building or hospital ward. Often has to be screened off and segregated into a work zone, often working directly alongside a live, critical, sensitive area. So what they would do in this situation, they would screen it off, they would extract air from their work zone and pump it through a filter, ideally outside. But potentially, if the filters in your filter bank are correct, it could be pumped into a sensitive area of the site. The important thing is the actual negative pressure. So without this negative pressure system, if it was just an equal pressure system, your dust, especially that microscopic dust or fume, could easily spread very, very easily into these live areas. So it's important to look at negative pressure in hospitals, especially. I touched on food processing plants, but it could be in retail, could be in offices, protecting other office staff from a work process that's going on next door. That's an example of a hospital environment where negative pressure was used very successfully recently on the COVID situation at John Radcliffe Hospital. What they were actually doing here, this wasn't a construction site, but this was a change of use of a particular ward, which happened to be a cardiac ward in this situation. But this cardiac ward had a positive pressure, as you would expect in a lot of situations. Fresh air being pumped in, filtered, but pumped in. So it's under pressure, positive pressure, to provide a fresh air supply into hospital ward. And this ward had to be changed from the cardiac through to a initial assessment COVID ward. So because this ward was actually attached to the rest of the hospital, there's always a risk that the COVID could spread to the remains of the hospital. So we had to change the ventilation from positive to negative pressure system. So this meant some significant fans and filters, and the fans achieving extremely high air change because of the nature of the virus. But it was an extremely successful way of containing it within that zone and stopping that virus spreading to the rest of the hospital. Using a range of fans from the 300 to 450 CF fans, high pressure fans, and running through a filter bank with HEPA 14 filters. Okay, so moving on to positive pressure. Now, this can be used in a multitude of different situations, but often used to protect areas, maybe within a building site that you want to keep completely clean. It could be a comms room, it could be a IT room, it could be finished rooms that have been handed over, perhaps in a hotel environment where you've deep cleaned areas and you need to stop dust from the remainder of the building site still in progress, stop that dust or fume spreading. As you can see in the image there of the house, the arrows, that's the air being forced out. So as we said at the outset, the fan would sit outside and you would pump in air to displace or push air out of that zone to stop any dust outside that zone migrating into that area you're trying to protect. As I say, it could be a comms room, it could be anything that you want to keep totally clean. Again, it's as effective as the negative pressure system in terms of what it achieves. If you're using the right filters, you can stop any dust or fume spreading. And like with the negative pressure, it's about the weight of the air. If we're pumping air into that room, that building, that space, it increases the weight of it. And because if it's heavier than outside, that's how we can really stop anything migrating in. It's often used and can be used and should perhaps be used more in construction to protect areas like breakout areas or project offices, welfare facilities, because you often find, especially in city centres where there's limited room for external of these type of spaces, they have to be directly alongside the building site. It could be demolition, going along outside these areas, it could be silica in the air. How can we effectively stop that microscopic particulate migrating into these areas, which should be perfectly clean? These are breakout areas, they're safe areas. And it could be achieved so easily with a positive pressure. So you'd have a fan outside in the work zone where the dust is, but put it through a filter. So you're filtering in under positive pressure into these clean areas. That would stop anything migrating in. And it could be situations where you might need to protect access egress. Often in hospitals, again, using airlock tents over doorways, similar to what asbestos companies would use, having a fan pumping in filtered air into an airlock tent. The idea being here, you would unzip the tent, walk inside and zip it up behind you. And you're then in an environment where it's completely protected, it's under pressure. There's no dust followed you in because it was under positive pressure. And then you progress to the clean side. So it can be used really effectively when you've got airlocks over doorways and so on. It could be confined space works. You can see on the bottom left there, a shaft and a fan ventilating into the basement of that shaft. And that's using a positive pressure. That's using fresh air forced to the base of that shaft to displace any hazards, whether it's dust or fume, out to atmosphere. Another case study on positive pressure, and in this case, a water industry situation where they were doing some maintenance works, refurbishments works, but it was in sewage. So here there's a potential of explosive gases. So using extract to extract that fume to atmosphere can often present a danger regarding electrics and explosive gases. With the positive pressure, as we said on that slide with the house and the arrows earlier on, the fan is outside the space, it's outside the zone, outside the house. And that means it's in a safe environment. And what they're doing here is venting in under positive pressure to displace those foul air and gases, potentially volatile gases, out to atmosphere. So it's a much more effective way of dealing with confined space. If you're in a basement perhaps, and you need to ventilate a basement, using positive pressure is a better way to ventilate that space rather than extract. It's a positive pressure, you're pumping in, you're displacing the foul air back out behind it. But because it's positive pressure, you do need to be aware that you could be, in that environment, you could potentially be pushing that hazard, whether it's dust or fume, into adjoining areas. So it's important to consider that. But generally, the positive pressure in that environment is a much better way to manage confined or restricted space ventilation. Okay, so like with any hazard, the key thing I think to look for is what we call the 3 C's: capture, contain, and control. It's a methodology that is most effective when we're trying to deal with hazards like dust and fume. And when we're looking at ventilation, it can be applied there by providing, whether it's negative or positive pressure. All comes down to the environment you're working with. We need to consider what we're dealing with in terms of the dust, what type of dust it is, if it's fume, what type of fume it is there gases, is there volatile atmosphere, and that way we can really understand what we're dealing with and put in an effective control. And that's really where the 3 C's of capture, contain, and control come into their own. So the type of fans that can be used and hired for this type of system for ventilation, with or without filters. You might remember at the beginning we spoke about negative pressure, extracting air out of an area. It doesn't necessarily have to be filtered, but it does depend obviously on what you're extracting. So some examples there of the type of fans and filters that can be used. You can see the fans on the top 2 and the bottom left, all centrifugal fans. So if you are working in an environment where it's potentially explosive and you're trying to handle air that is potentially explosive, then it's vital to use a centrifugal fan, as you can see in those images there, because the motor is external to the airflow. Unlike an actual fan, you've perhaps seen the 12-inch fans that you can get from hire shops. Problem with these, the electric motors are internal to the airflow, so you'll be passing volatile gases over electric. So always look for a centrifugal fan when you're dealing with ventilation in most situations. Okay, so that's the end. The key thing, I think, is to remember, look at every situation on its own merits, understand the hazards that you're dealing with, and look at who can be affected by your works. Is there going to be a neighbour next door? Is there going to be perhaps another trade on your building site that could be affected? look at ways of segregating areas and see if there's an opportunity to put in using negative pressure. But if you need to protect perhaps a smaller area on the site in comparison, if you like. I use the example of the welfare and the offices. It's a much smaller area or volume of air than the rest of the site. And that's really where that positive pressure can really be affected. Okay, so if you need any more information, there's the numbers on the screen there, and information at info@rvtgroup.co.uk, and the website www.rvtgroup.co.uk, where there's a whole range of white papers, information, case studies as well for your information if you need any more information.